All right, so I have problem number 19 in 2.5, which I am led to believe might possibly be exact. Oh, except it also has an initial condition. Okay, so the initial condition is y of pi over 4 is 0. And the rest of it is too disgusting to read. So, at any rate, it's minus 4y cosine x plus 4 sine x cosine x plus secant squared x dx plus 4y minus 4 sine x dy equals 0. So, what should you do first in the land of exact equations? Yeah, test to see if the frickin' thing's exact. If it's not exact, what do you get to do? Go away. You get to write, this equation is not exact. Done. No, actually what you get to do is write, this equation is not exact. Crap. Now what do I do? Right? It depends on how much motivation you have to solve. But what should I be checking here? Like, what's your test for exactness?
My equals nx.
Yeah, so think Clairaut's, right? So if this is the x thing, if I partial it with respect to y, I should get the same thing that I get out of this if I take the x partial. Right? So I should take the partial of this first thing with respect to y, and I get... So that's my is negative 4 cosine x. And then I should take nx, and I get negative 4 cosine. Crap. I mean, hooray, it's exact. Okay, cool. So I tested for exactness. Those two are the same. Check. Is exact. Bummer. I mean, great. I mean, I have mixed feelings about this. All right, so how do you solve an exact equation? What do you try to do? Yeah, you need to find the potential function, right? So you got to find a function so that all this junk here is fx, and all this junk here is fy. Okay, now remember, there's a bunch of different ways to find a potential function. The easiest of them is to start with the smallest thing. Well, the easiest to integrate thing. So which of these two is easier to integrate, fx or fy? Fy for darn sure, right? Okay, so take your fy, or your potential fy, right? So your 4y minus 4 sine x. And then you want to un-fy it. So how do you un-fy it? Yeah, you want to undo taking a partial with respect to y. Right? So you integrate dy, and you get out of this 2y squared minus 4y sine x.
Do we need to have our constant on there?
Yeah.
Yes. And this is the point that Chris was complaining about, because I should be adding a constant, right? But that's only a constant with respect to y. So there's possibly some k of x function. And I have a really bad habit of saying a constant dependent on x. Right? This thing is not a constant. This is a function of x. It's a constant with respect to the variable y. Yeah, this is totally Calc 3.
Yeah, it's like flashbacks.
Yeah.
Exactly that.
Okay, so once you're here, one method to find a potential function is to take the other thing and integrate that, and then try to like fiddle constants, right? That's my usual go-to when things are easy. When things are messy like this, what's another option? Walk away. No, come on, you can do this. So I think this is my f, right?
Yeah.
So where where did this first business come? Where did that M come from?
Derivative, hopefully, the derivative with respect to x of that.
Yeah, that should be the derivative with respect to x of this thing. And I'm pretty sure it's gonna be
Yeah, because you did that.
because I did the test for exactness, right? So all I need to do is differentiate this thing with respect to x and kind of play matching, right? So I'm going to hit this with a ddx operator. Really, it should be noted that I'm hitting that not with a hard ddx, but with a partial with respect to x. Okay, so if you take the partials with respect to x of this, what do you get? 2y squared, you get 0. Right? Because it doesn't depend on x. Okay. Minus 4y cosine x plus k prime. Okay, so now I just want to match. So you got a minus 4 cosine x up there? Sweet. Check. All right. So that means that k prime of x is that stuff. Does that all depend on x? Yep. Cool.
And since we checked in the beginning, that's all we need, right? We can just...
Yeah, so I can assume that this is true. That's going to be k prime of x. So now I'm left with this kind of new problem. K of x is going to be the antiderivative of that jazz, right? 4 sine x cosine x plus secant squared dx, right?
I think this is where you're supposed to remember the sign of the double angle formula from trig.
That's way harder.
No, you can do yourself.
I don't remember any of that. Do easier things. So make this 4 times the antiderivative of sine x cosine x plus the antiderivative of secant squared x. And then you guys are muttering that secant's easy? So you got 4, I guess I'll need some space. So you got 4 times something I'll deal with plus tangent x.
See?
Okay, so what do you do here?
Oh, I do u things.
Yeah, do u sub, so you let u be
Sine of x.
sine x. Then du is cosine x dx. You got one of those? Oops. I lost a dx there somewhere. You guys let me do it.
I was just putting parentheses.
Crap notation. Okay, so I got here the integral of u to u.
So sine squared x.
So that'll be 4 sine squared x over 2 plus tangent x. And then,
Do we need to see on this one?
yeah, we really should have a constant. That's mostly out of good form and not out of necessity in this problem. Because, okay, where was I? Because,
Use your best value for k of x.
yeah, so that was k of x, right? So this thing here needs to go into that thing there. And what was this thing supposed to be equal to? Yeah, that's your f, which you want to set equal to a constant, right? So it's not just about finding f, it's about setting that f equal to a constant. So you should have 2y squared minus 4y sine x plus, oops, 4 over 2 is 2, last I checked, sine squared x plus tangent x. And then here's the part where the constant doesn't really matter much. You're adding a constant, and then you're setting it equal to some other constant. Yeah, so you may as well shove the constant over and stick them together. Okay. That is your solution.
We have the initial condition.
Ow!
This is where it gets hairy now.
Yeah. I was really hoping. Okay, what else should you do here? You should try one thing just briefly. It's not going to work in this case. You should think about doing something. What should you think about trying to do? Yeah, you should solve explicitly for either x or y if possible. You going to be able to do that here? No. You try it, right?
Sure.
Briefly.
On a whiteboard and on a paper.
Okay, so y of pi over 4 is 0. What does that mean I should be plugging in?
0 for all y's.
Plug in 0 for the y's. Okay, that's easy. I got 0 minus 0 plus 2 sine squared of pi over 4 plus the tangent of pi over 4. And this should equal c. Why does this feel weird? Yeah, mostly it feels weird because I plugged in something for both y and x, right? Yeah. But whatever. Okay. So what's the sine of pi over 4? Good answer. 1 over the square root of 2. And then when you square it, you get 1/2. So times 2, that's going to be 1. Plus the tangent is also 1. And so you get c.
Fanciest way to add 1 and 1 together.
Yes. That is probably the biggest pain in the ass to add 1 and 1 together. So you can put c is 2. Cool. Questions, things?
It's getting it, they solved it explicitly for y, and that's where I got lost.
Oh, they tried to solve this explicitly for y?
Yeah, and they got sine x minus the square root of 1 plus tan x over 2, minus tan x over 2. I don't know how that.
Oh, yeah. So the way you would solve for y, it's a horrible trick that you might learn in a pre-calculus class.
Would you just use like the quadratic formula, so to speak?
Yeah.
Oh, that's good.
Oh, that was.
Hey, this is the quadratic control for y.
Okay, maybe we should set that up.
Oh, yeah.
Right? Move everything to one side, and then everything that's attached to a y squared is a, and everything that's attached to a y is b, and everything else is c. And then, sure, go nuts. Don't waste your time with this.
Remember, Joe, when I showed you that really big problem that I was working on, and I had to do that same strategy 3 times?
Yeah, so this is the kind of strategy that you should know exists. You should also know not to do it unless you absolutely have to. But you should know the strategy exists. Cool? Also, it's not an explicit solution anyway because you're going to get a plus or minus. So yeah, I personally would have looked at this and said, well, that's quadratic in y, and there's a bunch of x's shoved in a bunch of different trig functions. I'm probably not going to be able to solve this for anything.
Was it an ABC? Will you use that to solve it, or is that just kind of the
Oh, you
answer?
cram this in the quadratic formula.
Oh.
Right,
okay.
so then y is negative 4 sine x plus or minus the square root of 16 sine squared x minus 4 times 2 times this shit all over 2 times 2. Well, at least the denominator's easy.
Wow.
And then you multiply this crap out, and you probably notice a trig identity in there. Oh no, the sine squareds cancel. Yeah, I mean, you notice some stuff.
Yes, and you have to pick, because your initial condition, so you'll get either a plus or a minus, whether you pick one or the other.
No, you won't. You shouldn't, because your initial condition so this is a level curve of a function, and you're trying to force it to pass the vertical line test. It probably doesn't. You guys see that? Like this the solution curve that I'm getting here probably looks something like this. Right? And then you're trying to fit this thing into but I want it to be a function mold. Like, I want y to be a function of x, but it's not. It's not gonna be. So you're gonna end up doing this thing where you kind of truncate the bottom half.
So the two different.
And yeah, you can say the point pi over 4 comma 0 is on one or the other of those pieces,
Oh, that's how they picked it up.
right? And that's how they picked it. But that's not that's not better than, say, numerically solving for x, and then it's just more possible.